Eventually, John Harrison would win the £20,000 prize for a clock that was accurate enough.
Since the dawn of mankind, human beings have wanted to measure time. Originally, the periodic motion of the sun was our main reference for timekeeping. Using sundials, we measured time in days, dividing them into hours, minutes and seconds.
Today, the motion of the sun is no longer our standard of timekeeping. Here, at the University of Innsbruck, we develop cutting-edge numerical simulations crucial in the design of IQ Clock's next generation atomic clocks. The need for better timekeeping devices than sundials and hourglasses became especially clear in the 17th century.
Surprisingly, in order to determine our location, we must be able to measure time. The location of a ship at sea can be described by two coordinates. The latitude coordinate tells us where we are in the vertical direction. The longitude coordinate does the same for the horizontal direction. To determine our latitude, we can measure how high in the sky the sun and the stars are. But because the Earth rotates, determining our longitude is more difficult. With the help of the sun or the stars, we determine what time it is at our location. If we also know what time it is back home, and this requires bringing a good clock, we can calculate how far from home we are in the longitude direction. In 1714, the British government therefore awarded prizes for the development of accurate, seaworthy clocks.
Eventually, John Harrison would win the £20,000 prize for a clock that was accurate enough. His clock used the idea of a pendulum, but a very intricate one, based on springs and cogwheels.
In spite of motion and humidity at sea, Harrison's clock could run for 5 days before being off by 1 second. Very impressive. The first quartz clocks in 1927 were not that much more accurate.
We measure the accuracy of a clock by the fraction it goes wrong. For example, a day has close to 100,000 seconds, so 1 second wrong per day is 1 part in 10 to the 5. Today's atomic clocks, based on strontium atoms and superradiant lasers, go 15 orders of magnitude further, culminating in an accuracy of 1 part in 10 to the 20.
The first of the atomic clocks that Laurin talks about was made in 1949 at the US National Bureau of Standards. It was still less accurate than quartz clocks, but this would change soon. Today, atomic clocks are the most accurate clocks that we have. To learn more about what atomic clocks are, how they work and what we use them for, watch the next video in this series.